Ladies and gentlemen, let me talk to you today on a very important topic, which is biorisk management. Just for the students' sake, what is biorisk? To make it very simple, biorisk is, biosafety, biosecurity, and its risk. I mean, simply, and when you say risk is probability of harm occurring or severity of the harm, these two things, probability and its severity. So if there is a risk from the biological material, the labs, and the individuals, let's discuss it today. And now how to manage that? And that is that we have three pillars of it. First, to assess it, mitigate it, and then performance. To make it more simple for you, biorisk generally refers to the risk associated with the biological material or infectious agents, what you call it, pathogen. So this is since 1990, we use these words very, very frequently. But the overall goal is that when we talk about biosafety and biosecurity awareness, for what? For biorisk management efficacy, and the ultimate goal is the global health and sustainable development. Now, we came to a word biosafety. The biosafety is the discipline that address the safe handling and containment of infectious microorganisms and hazardous biological material. So that is when you handle them and when you contain it for what? So that we prevent the large-scale loss of biological integrity, both ecologically, the biodiversity, and the human health. So these preventions mechanisms that in the where to prevent all this? Of course, first is the laboratory where you work, and all the individuals of the laboratory, all the equipments of the laboratories. Now, this term containment, how to contain it? I mean, this English term is basically the safe methods of managing, handling, maintaining of infectious material of the lab environment, or making the lab environment such that it automatically addresses all those questions. But the ultimate purpose for this is to reduce or eliminate exposure of the laboratory work, other person, and community at large, the environment, to potential hazardous material. And how to do that? Basically, we have methods for it. We practice those methods to contain it. We train the personality, the human personnel in the lab, around the lab, and even in the general public, awareness and safety of the equipment. Now, when we talk about the main component of this all biosafety and biosecurity we are discussing is the lab. And labs are basically around the globe divided into 4 groups. One, we call it the BSL1, the labs that are basically being taught, used for basic teaching and research. That is the main, and majority of the world labs are, BSL1, because it's basically used for teaching. Then BSL2, where the basic, some research is going on at a master PhD level. BSL3, little more advanced lab, and BSL4, the advanced where vaccine development, where you develop different drugs, etc. And that is, these are the 4 basic classifications. So mainly you students are, dealing with BSL1 and BSL2. This was one. The other classification that we have to make it the risk groups. When we talk about infectious, pathogens and material, the NIH has basically guidelines to define those risk group as 1 and 2. One are those that are that are associated with the disease in the healthy adult human beings. And risk 2 is agents that rarely cause diseases, serious really it is serious, and which preventive or therapeutic interventions are often available. Risk one, we may be having certain groups that it's not with the common in the human, and if it goes to the humanity at large, you may be in trouble because you may not have already therapeutic mechanisms available for it. But for risk two, this is the group which is infectious, but which we know that how to treat it. And these are classified based on the pathogenicity of the organism, its virulence, invasiveness, etc. For example, mode of transmission and host range, availability of preventive measures, availability of effective treatments, and some other factor. So what we discussed already is one, the different kinds of the lab, two, the different kind of the risk group of the biological material. Now, standards biological practices that we usually conduct in the lab on an almost daily basis are first that all the procedures are carefully performed so that minimize the risk. Work surfaces are decontaminated almost every day. All cultures, stocks, and other regulated waste are decontaminated every day. Materials are decontaminated. And even if it goes out of the lab, it is such that it doesn't contaminate the environment. It is in the safe place where it is discarded, or the mechanism is available. Special containment devices is available at the lab and outside the lab where you dispose it of. And all the personnel uses lab coats, gowns, or uniform whenever doing labs, and gloves are must, specifically for those people whose skins and hands are, having rashes or having, so that nothing goes in their body through those rashes. Here I just show you, because Dr. Muhammad Ali has recently in a process of establishing a BSL2 lab. In fact, he has established one in the biotechnology department. So this is a general structure of a biosafety lab 2, where all these things are available, like eye wash available, autoclave is outside the main facility within the room, but not in the facility where you work, because it may having certain kind of gases, etc. Self-closing doors, flow of air is controlled, no plants, no research animals in the lab, hand washing things and others are available. So these are the basic requirements of a lab, and this is a kind of a structural design of a BSL2 lab. Other thing, this I show you pictoriously to make more you aware of about the thing that you can and you can't do in the lab. For example, you can't eat and drink in the lab. You can't smoke in the lab. You cannot handle your contact lenses, for example, or cosmetics within the lab. Excuse me. So these are our open-toed shoes, for example. These are some of the basic things. Excuse me. So then containment, there are some primary containment where you protect the humans, the personnel, and the laboratory environment. And there is some secondary containment where the environment and other external to the laboratory exposure of infectious diseases. So these two kind of containment are basically to contain to avoid spreading of the material. Now, biorisk assessment. There was already, like you accredit your labs for the ISOs. Excuse me. So those are process of evaluating the biorisk lab, biological labs, 18001-2007 OASIS. We have taken it from there, where you do advocacy or this has already been, by Kaplan, risk analysis that contains how you can, three specific questions that you address. One, what can happen? Number one, what is the chances that it will happen? If it happens, what are the consequences? Here, now, what is the management? This was basically these protocols that if you can accredit your lab, what we call it SEN workshop agreement, CWA, and that CWA 15793 in 2008, you can, if you follow they have already designed those workshop agreements. That first, what is biorisk management? Biorisk encompasses biosafety and biosecurity, where hazards are biological agents and their product, establish systems and integral into day-to-day operations of the institute's organization, both in normal times and in emergency. This is how we talk about it. First, CW gap analysis, that you must have a BSO, what we call it, biorisk manager, a staff that looks after all the labs in the department, ensure the requirements of the standards, interacts with different sections involved both within the department and inter-department, and manages tasks and responsibility. Now, two terms. One is biosafety, other is biosecurity. What is the difference between the two? Biosafety is to protect people from the germ very easily. You protect your people from the germ, and biosecurity is you protect germs from the bad people, that they don't take germs from you and use it for bad things. So this is the basic difference between the two words. Here, again, when we talk about valuable biological material, VBM, so on one side, biosafety, containment, for example, safe equipment, good manufacturing practices, waste management. On another side, for biosecurity, basically for the lab management, you need protection, control, and accountability. So these are the basic principles for it. And when you talk about biosafety as controlling biological risk through your teamwork, there you need protection of the people and environment, of course, yourself and your colleague. On the other side, implement best practices to achieve this. And finally, comply with the regulatory environment. The basics for all the global things are available. So here, the first is that you pre-incident, God forbid something happen, the likelihood that can happen, you have to have an eye on it. And the second thing is, if an incident happens, what is the post-incident consequences? What can happen? It can have loss of, life of people, misuse of assets, economic, societal, psychological, political. If something happens, if something goes out of the lab, that will have disaster for the whole society. So here, again, it's too crowded a slide, but what we talk about is that when we talk about biosecurity, it is basically the environment, vector, time, host, pathogen, whatever the things are involved. For that, on one side, it can harm biodiversity, the microbial world that you have outside that are living as a symbiotic with you. There are maybe high consequences agents. If it goes there, then it may become invasive, and that invasiveness both for pets and plants and humans. And also you have to keep an eye on the international trading, how you send your material if it has something. So those all basics, policies and things you discuss, and then of course the zoonosis, weather, climate change, etc. You have to understand all these philosophies when interdisciplinarity when you talk about security. Now, for all this, one word comes internationally commonly used is the responsible conduct of science. And how can you make research responsible? The basic is that you avoid risk intended or unintended. You don't do it. but because of your material, your lab, your equipment, it may happen. So that is that the unintended consequences too you have to keep in mind. For example, something may be released accidentally, something go on your lab coat, something infect a personnel, he may not be knowing, he may have skin rashes, get something in and go out of the lab. Those kind of things that you have to, and something may be stolen, diverted, maybe misused. All these, if we have awareness, this workshop is basically for that purpose, that we make you aware what can happen. And for that, you need a leadership. Mohammed is, becoming a good leader. For leadership, what you need that your students and yourself, you do the basic, behavior, training, and communication of the people that are linked to you. You be a role model. And for that, you need to have a trust and humility as a leader. You execute and manage things that are really good, design and innovation. So, when we talk about risk management, assessment, mitigation, so the management standards are here. Monitor and review, identify the risk factors, and what can happen. So these are the basic things. I summarize here a bit of, the leadership behavior, and that is one that obeys the international legal framework and standard. You have some national regulation, you are aware of it. Organization culture, the places that you are heading, if you are a chair of the department, you do regular awareness programs. You have beliefs and attitude towards your personnel, you have management systems. Your culture of your organization is such that you have very good communication with all your colleagues. And if you do all this, you may be able to avoid it and you may be able to manage the risk that is there. So you should, as a leader, be understanding what is my risk? What will I do about it? How do I do it? And for that, you have to assess the risk, what risk can come, you have to mitigate, and then you have to perform. So the general considerations of the lab, basically, you have to determine your controls, you implement your controls, you review effectiveness of the controls in all the lab. If you are a department head, if you are a faculty dean, you have to have a continuous watch on all the labs that are working in your faculty. And then, you do all have indicators and you tell them, and you should be knowing what is the outcome of all this. I'm trying to have a leadership behavior, but because of time, I'm not going to talk about all of the system. But leadership behavior as a role model, as a decision maker, as involving every staff and feedback, and then the management system that you have, visible biorisk management systems, safety, security, work management, training, awareness, and on the other side, personnel behavior, professionalism, security awareness, compliance, personnel accountability. So this is the belief and attitude that will take you there. The key messages are: understand biorisk, biosecurity, biosafety, biorisk management. This workshop, when you go out of this workshop, you should be knowing at least these basic terms, what we are talking about. And AMP is assessment, mitigation, and performance. Very simple model of managing biorisk. And then you implement all this, and you have awareness about all these issues that are there. So, and again, I think this faculty, Madam Dean is a really capable person. They should have a vision of the faculty that regarding biosafety and biosecurity, that they are excellent, responsible, safe, and secure life sciences research activity in the faculty, which promotes public health. But basically that comes from communication, education, training, and capacity building, interaction of different stakeholders, chairpersons of the department, professors, and all that. And then that goes to research excellence. They have ethics. They have biosafety and laboratory biosecurity. That goes to management and responsible conduct of science. Why we are talking about all this? This is, I just very briefly talk about dual use of education. Dual use of education is you do science for the peaceful purposes, where from your microbiology lab, from your plant sciences lab, animal science, that goes for you do a lot of good things, diagnostics, drugs, vaccines, antivirals, everything comes for the peaceful purposes. But the same lab can be used for weapons, bioweapons. So this is what you should be understanding what it is. Just one slide. The COVID-19, was it the worst pandemic in the life of the human beings? No, it was not. But because of media, we understand. Here I have shown very briefly all the pathogens, all the pandemics that human had been through right 500 years back, plague of Athens to COVID-19. In between the Black Death, the third plague, and all this, and the number of deaths that we had because of that. And if that you relate our population of human at that time, when it was 1 billion, now today 8 billion. So that was too big. So what we should understand that we may not die because of, the number of deaths from COVID are less than air pollution that caused the death of over 8 million people globally, every year, which is about 1 in 5 deaths each year, just for air pollution. So we should understand, and we as a scientist should be talking about that there. It's another way of, having all that. So, but what the problem in this today world we have is basically the disinformation and the misuse of social media. Now, the new kind of biowarfare, you may not be deploying bioweapon, yet you may be getting the result because people will be reluctant to vaccine, people will be reluctant to, they may be having several rumors, somebody may be using different kind of treatments which are not, and people will delegitimize science. That is the more dangerous. They will say science cannot do anything for us because it takes time to have vaccine out of the lab, or some kind of diagnostics of the lab, or some kind of medicine of the lab. So, but then those people for misinformation and disinformation, they will delegitimize science. That's why we have to train our students that they should be proactive in defending science. That, how can we use science for the good of the human being? So, ladies and gentlemen, what we are going to do is, I just talked to you about one more important thing, BWC, Bioweapon Convention. When I say that a leader should be understanding both national and international regulation, one of the international regulation is BTWC, Biotoxin Weapon Convention. That is, that prohibits that has some certain, legal bindings on us that we have to use those material very carefully, and we have to have responsible conduct of science. And if there are some, biological material that can be used weapons of mass destruction, we have to stop it. So for this, we really have to work for preparedness, safeguarding peaceful uses of life sciences. Nobody can stop you from peaceful uses, but you have to be vigilant that it is not misused. No, in all this, what is your role? As a young man, all are a woman, you all sitting here, your role is, if something happened, you at least can have whistleblowers. You can say, oh, that lab is really very dangerous. That lab's, waste material is discarded in an open ground, for example. And then if you are a dean, your faculty, please, you have to have an eye on all the department. If you are a researcher, your lab, you are important. Funding agencies should not be funding people that there is a dangerous, and then the publication that are, published, and of course the government, regulatory agencies, they should be known. So you, even if you are a student, you should be one of the, person who can really work on it. So now, for this, we use the terms of biodiplomacy, multi-track biodiplomacy. What is biodiplomacy? That you can work, you can talk about this subject more and more. Unfortunately, some of even the faculty member, I'm sorry to say it, but I want to say that they sometimes say, oh, it's biotourism. They go abroad, they just enjoy, and there's a Western agenda, blah, 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 blah. Because they never been outside their own laboratory. Sorry to say, they are homegrown people from the, to the PhD level, and they've never been anywhere. And they don't go out of their track, their own smaller niche. So you have to understand. Track one is the government. Track 1% mediation dialogue, influential elites, and institutional workers. They all have to work together to address this. Possible threats of biological weapons. There are threats for livestock. For example, avian influenza, Nipah virus, mad cow disease. There are then weapons for food and water that can be contaminated. Staphylococcus, for example, salmonella, for example. There are things for agriculture, vaccinia. If you throw some seeds there, for example, and of course, human HIV and all others that now, corona, we have to be very, very careful. So I talk about BTWC, but in BTWC, there are different articles that addresses all this, that you can have justification for peaceful uses, what we call it, but never under any circumstances you can develop, stockpile, or use microbial or other biological agents for the things that you cannot defend, that why you are keeping it. So those loopholes we are discussing every 4 years, internationally, all the stakeholders, and we discuss all this. For management system components, of course, there are security ways, there are transport. If you transport things, how should be done? How you disinfect it, for which material, decontamination, equipment maintenance, accident and incident investigation, ways and means, emergency response, healthcare, and another side, risk assessment, toxicity of an organism or of material, safety of human and others. We discuss all this. So here, just how can you save at least your surroundings? If it is sharp material, for example, needle, razor blades, where to keep it, if you know it. If you don't know it, what to do it. And if you have some material, you should understand, is it infectious? If it is, where to go? If it is not, how to treat, how to done, etc., etc. And finally, for leadership, sustainable biosafety and biological security program is really very important. And that is from developmental system, fundamental research, energy, agriculture, public health, food. All this I have kept it to you in one slide for partnership, for ethics, for management, quality. You have to have your loyalty, your vision of the whole system, growth, honesty, all these characteristics that a leader should have. A leader can be a lab head, a PhD scholar that he looks around, he can be a leader, even the department chairperson, and of course the dean, they are the leader. And here I have tried to document the key roles and responsibility of everybody that works in the lab. Facilitator, operator, facility operator, for example, somebody uses some equipment, how should he be doing? Biosafety committee, what is it? Department biosafety committee, institution biosafety committee, biosafety coordinator. These are the basic criteria. I will be giving you a copy of all this that you should be implementing. Then who are the authorities? What are their role and responsibility? For example, PI of a project, principal investigator. How should he be behaving? And then the review committee of the, I hope our faculty has an institution, bioethics and biosafety committees and biosecurity committees. What is their role, how they do it? And then, of course, departmental committees, they must be regularly meeting and talk about it. These are different international projects. Like one of the project is diffuse. This diffuse project is basically, the diffusing the threat of bat-borne coronaviruses. Our lab has one of the projects. That's why I talk about it. That this project is a multinational project from China, UK, and US, and they are trying, because bat is one that has contributed a lot of viral disease to human too. Corona is one of the example. And there is another project, another big project, international, which is called DRASTIC. DRASTIC stands for Decentralized Radical Autonomous Search Teams Investigating COVID-19. They're looking at it, whether it was really in a wet market, whether it was from the lab, and all those basics that they are working on it. This project is already. And I hope you enjoyed this. Thank you.